Hey there, so we're going to look at two other types of contrapositive proofs. We're going to look at one with division and one with inequality here. And again, we're just always going to be using contrapositive for the methods here and for the homework. But I will remind you, just like we saw last time, is that if you're looking at the conclusion of a statement and this is simpler than the hypothesis, which would be this first part, you're probably going to want to use contrapositive proofs, and that's just going to be really helpful when we come back from Thanksgiving break and you're asked to determine and pick direct versus contrapositive. So get yourself ready for notes, and we're going to get started. So here I'm going to use contrapositive, as I said, and the first thing that I want to do is write out this new idea. So the idea is that if y is not less than or equal to x, then y cubed plus yx squared is not less than or equal to x cubed plus xy squared. And again, I might write that out then in a more positive way. So if y is, so the idea is that if y is not less than or equal to, then y must be greater than x. Similarly, then y cubed plus yx squared is greater than x cubed plus xy squared. So now that we've written the contrapositive statement, that means that we're actually going to end up wanting to prove this using the methods that we've had before. So here we'll say y is greater than x, and remember that what we want is this more complex inequality, and so what I would do in this case is multiply both sides by y squared plus x squared, and make sure that when we multiply both sides of an inequality, we justify why the sign in between doesn't flip. So we'd say since y squared plus x squared, have a little parentheses issue, that's all right, we can fix that little friend, is greater than or equal to 0. Since we're talking about squares, those are always going to be positive, and addition of two positive numbers is also positive. If you want to write that out, I don't have full space for that, but make sure that you're using this justification here. And then we end up with y cubed plus yx squared is greater than xy squared plus x cubed. Little commutative property rule will then end up giving us what we want, which is x cubed plus xy squared. So by proof of the contrapositive, spelling is not my forte, if y cubed plus yx squared is less than or equal to x cubed plus xy squared, then y is less than or equal to x. Running out of space a little bit there, like so. So remember, with contrapositives, it's nice to rewrite it and use that correct inequality symbols. Now let's look at a divisibility one. For number 2, suppose a is in the integers. If 4, and this means is not divisible, so it's like an equal sign with a strike through it. If we have this, we say is not divisible. So 4 does not divide a squared, then a is odd. Again, I want to use the contrapositive. So if a is not odd, meaning a is even, then 4 does not divide. So then 4 divides a squared. So that's what we actually want to prove by writing out the contrapositive. This is another sign we want to use contrapositive, is that if you have a negative or a negated operation in this setup already, because when you negate it again, you get a nice roll like that. So suppose A is even, so that would say 2x, where x is in the integers. Now I'm interested in A squared, looking at my conclusion. So since I'm interested in A squared, that would be 2x times 2x, which would then equal 4x squared. Now we can say x squared is equal to y, which is in the integers, by closure under multiplication, since exponents are a type of multiplication. So a squared is equal to 4y, which implies that 4 divides a squared. And finish up, as always, by proving the contrapositive, or proof of the contrapositive. Because remember, this isn't the exact proof we're asked for, we're proving the contrapositive. If 4 does not divide a squared, then a is odd. Hopefully these two other examples help doing a little practice with contrapositive proofs, and you'll be all set to go for your quiz on Thursday because there's no school on Friday. We'll be doing conferences with parents Friday and Monday. So if you end up wanting to work on Friday, catching up on any missing assignments that you have, all of that is just fine. Talk to you later.